Hello everyone, welcome to another video on the Data Perspective channel. So in our today's video, we'll be looking at how I went about pre-processing of our data for machine learning. If you can remember, in our previous video, we talked about the data analysis aspect for our sleep, eat, lifestyle data. So in today's video, we'll be looking at how I process that data for machine learning and the various models I use to carry out my predictions. I'll also be telling you the reason why I picked each of these models. So without wasting time, let's dive right in. So the first thing I did was to print my data frame, just the first 3 rows, to view my data set once more. And when I was done with that, I went ahead to drop the irrelevant columns in this data set. For example, the person ID column, which will not be relevant to our machine learning. I also dropped the age column. If you remember, when we're carrying out our data analysis, we've already created categories from this age column, so it will no longer be necessary to leave this age column in our data set. I also dropped the blood pressure column because if you remember, when we're also carrying out our data analysis, we also separated this column into the systolic and the diastolic column respectively, so there will be no need leaving the blood pressure column any longer. So I dropped these 3 columns from the data set, and when I was done with that, I checked for the variance of our numeric data. I used the select_dtypes method to get only our numerical data, and I used the .var method to look at the variance in these columns of data. So if you look at this, you see we have high differences in their variances. So what we have to do now is to pre-process and scale our data so that the various columns will be on the same scale. So I had to use the standard scaler for pre-processing of the data. I imported standard scaler from sklearn.preprocessing, and I used the fit transform method to fit and transform the data. After that, I created a scaled data frame from our scaled columns. I used the pd.dataframe method, passing our scaled data into our data arguments and the various columns into the columns argument, and here we got our scaled df. If you look at this data frame now, you could see that the rows of data in this data frame has been scaled. The next thing I did was to go ahead and look at the variance once more using the .var method, and you could see now that all the numeric columns are on the same scale. Now the next thing is to look at the categorical columns. Machine learning doesn't work with categorical data, it has to be in numbers, right? So I have to convert our categorical columns into integer data type, and to do that I just had to first of all get my categorical data by using the .select_dtypes method and excluding all integers. I saved that as the cat_data, and when I was done with that, I dropped the sleep disorder, since that is going to be a column which we are trying to predict. I used the pd.get_dummies to convert our categorical columns into integers. I also went ahead and saved this as the cat dummies. So now if you look at this table, you see now that our categorical columns have now been converted into integer data types. So for example, our gender column, we have female as 0 and male as 1. Now I went ahead to use the pd.concat method to join our numerical scaled data set, which I saved as scaled_df, and the categorical data set, which I saved as cat_dummies. And I saved this data frame as new_dt. So this is our data frame now, where we have our sleep duration, quality of sleep, physical activity, and etc. So for the numerical columns, they've all been scaled accurately, while for the categorical columns, they've all been converted into integers also. The next thing I did was to go ahead and check the class balance of this data set. Using the sns.canplot method, you can see that we have more no disorder rows of data than sleep apnea and insomnia, and this is going to affect our model because the class is imbalanced. So to make this data set balanced, I went ahead to import smooth from imblearn.oversampling. Here I saved our new dt data as our x variable and our sleep disorder column as our y variable. Using the smooth library which we've imported, we're able to fit and resample our data set. Okay, so after resampling, I went ahead to check the class balance once more, and now we can see that our no disorder, sleep apnea and insomnia are all having equal number of rows. I can now go ahead and convert our target variable into integer data type also. To do that, I use the pd.getDummies method, passed in our now resampled y data and set the asType method as integer. So you can see we have insomnia, no disorder and sleep apnea. The next thing I did was to import the train_test_split method from the Scikit-learn.model_selection, since we would have to have our strain, stest, ytrain and ytest. And to do that, I passed in our s resampled as our s data, then our y value which we've gotten earlier as our y data. I set the test size to 30% and also specified a random state of 21. So now you could see that our resampled chip and our y chip are 657, 29 and 657,3 respectively. So from this you can see that we're working with a multi-labeled target variable. So to be able to create a prediction for this, we can only work with some specific machine learning models. For example, this logistic regression classifier. Why? Because it works well for linearly separable data, and not only that, it provides a probabilistic output which makes it useful for multi-label problems with overlapping classes. Since I'm working with a multi-class or a multi-label data, I had to first import one versus rest classifier from the Scikit-learn.multiclass and then import logistic regression from Scikit-learn.linear_model. Now to create the model, I used one versus rest classifier and pass in the logistic regression, saving this as LRO_model. The next thing I did was to fit the S train and the Y train to this model. So if we scroll down, we will see that looking at our classes and our multi-label, we will see our classes. We have 0, 1, 2 as our classes, and the multi-label question came out true to identify that this is a multi-labeled model. When I was done with that, I used the .score method to check the accuracy score for the S train and Y train, and also for the S test and Y test. We got an accuracy score of 89 for the training score and an accuracy score of 90 for our test data, which are not very bad. So now I went ahead to use the model to predict on our S test, and I save this as our y_prediction to get the class labels. I also imported accuracy_score, precision score, recall score, F1 score, and the confusion matrix from Scikit-learn.metrics. With this, I was able to get our accuracy score for our Y test and Y predictions, the precision score for Y test and Y predictions, the recall score, and also the F1 score. And if you take note, I set this average to micro since I'm working with a multi-label or multi-class problem. Another model which I used was the linear SVC model, and I made use of this because it is suitable for large-scale data sets due to its computational efficiency. It is also effective when classes are linearly separable or nearly so. And this linear support vector classifier model can also be used with one versus rest strategy for multi-label classification. So to use this, I had to import the one versus rest classifier from the Scikit-learn.multiclass and also import the linear SVC from Scikit-learn.sva. I created my model SVC_model using the one versus rest classifier, and I passed in the linear SVC. The next thing I did was to fit this model which I created to the S train and the Y train data. So when I was done with that, I used the .score method on the S train and Y train to get the accuracy score on the training data and also to get the accuracy score on the test data. So we got 91% and 89% respectively. Next, I went ahead and used our model to predict on the S test, and I saved this as our Y-pred. I could now go ahead to get the accuracy score, precision score, recall score, and F1 score on our Y test and our Y predictions. If you also take note, I added this average parameter equals to micro because we're working with multi-label or multi-class problems. The next model I made use of was the decision tree based classifier, and I used the bagging classifier. This was done because bagging decision tree classifier is used to reduce overfitting by combining multiple decision trees. It also works well with imbalanced data sets by improving generalization and captures non-linear relationships in data. So same process, I initiated my model using the bagging classifier and I passed in some argument. For estimator, we passed in our decision tree classifier, then we specified our mass underscore samples, our maximum features, set our bootstrap to false and our bootstrap underscore features to false also. Using the one versus rest classifier, we passed in our model which we've created earlier as bagging 1. I went ahead to use this model to fit our S train and Y train, and also I checked the accuracy score for the S test and Y test data. We had an accuracy score of 88%. When I was done with this, I also used this model to predict on our S test so that I can get my Y prediction class labels. With this, I was able to get the accuracy score, precision score, recall score, and F1 score for our Y test and our Y predictions, setting the average argument as micro. The last model which I created was the MLP classifier, which is the multi-layer perceptron classifier. This is a neural network based model that captures complex non-linear relationship, and it is suitable for multi-label classification by learning intricate features interaction. This model works well with large data set and can adapt to different distribution within our data set. So I first of all imported the MLP classifier from the Scikit-learn.neural_network. I initiated my model using the MLP classifier. Now I could now go ahead and use the one versus rest classifier, passing in the MLP to create my model and fit this model which I just created to the S train and the Y train data. Next, I went ahead to get the accuracy score of this my model on the S test and the Y test data, and we got an accuracy score of 88%. I used my model to predict on the S test and we got our Y-pred class labels. With this, I was able to get the accuracy score, precision score, recall score, and F1 score for the Y test and the Y-pred. If you also take notes, you'll see that we also set our average parameter to micro. I could now go ahead and compare the various model and check which one was more accurate. To do that, I created a data frame using the pd.dataframe and passed in all our model name as a list. I also passed in the accuracies as a list, the precision scores as list, recall scores, and F1 scores as list. With this, I was able to create a data frame from it. So if you look at this table, we have our metrics where we have our accuracy, precision, recall, and F1 score, and we have our various models. So for accuracy, you would see that Logistic regression model had the highest accuracy score, which was 90%, while for precision, the MLP classifier had the highest precision score of 92%. If we also look at the recall, logistic regression and the linear SVC came top with the highest recall score of 91%, while for the F1 score, logistic regression and linear SVC also came top with the highest F1 score. So the next thing I did was to create a bar plot to show only the accuracy scores of each of these models. And to do that, I first of all created a Pandas data frame containing just the models and their accuracy score. Then I used the dot plot method to plot a bar graph showing these models. So if I scroll down, you can see a visual representation of our models and their accuracy score, with logistic regression coming up as the highest, linear SVC taking the second position, Bayesian decision tree based model and MLP classifier following up. So that was all for our data modeling. At the end of this, I wrote briefly on our data modeling, and I said another possible solution is to use machine learning algorithms to create predictive models based on client data to identify the characteristics that most influence the risks of sleep disorder. Once these characteristics are identified, the health insurance company can use this information to determine the premium they want the client to pay. Thus, the availability of machine learning based predictive tools enables health insurance companies to take a more efficient approach in their decision making. I said the case of sleep disorders can be treated as a multi-class classification problem. The goal is to predict whether a patient has any of the sleep disorder or not. The target variable in this case can be specified as a multi-variable, where we have three classes of variable: no disorder, sleep apnea, and sleep insomnia. I use the one versus the rest classifier for my data set as it is a multi-class data. However, by design, it doesn't provide feature importance directly, as feature importances are usually related to specific binary classifier like decision tree or random forest. One versus rest classifier is a strategy used for multi-class classification, which typically wraps another base classifier to extend it to multi-class problems. A wide range of machine learning algorithms was used to solve the problems. I said I used the non-linear classification model, the linear classification technique, decision tree algorithm, multi-layer perceptions. You can go through this notebook to see what I wrote in regarding each of these models I used. So for the conclusion and recommendation, I said the report's comprehensive analysis underscores the multifaceted nature of sleep patterns, revealing that various factors can significantly impact an individual's sleep quality, potentially leading to different types of sleep disorder. Key insights extracted from the heat map analysis highlight strong correlation between occupation and blood pressure values with the occurrence of sleep disorders. This information presents a valuable opportunity for health insurance companies to prioritize follow-ups with specific occupation groups, notably software engineers, sales representatives, whether further data collection is warranted to yield more precise conclusions. Moreover, the study indicates a substantial influence of an individual's level of physical activity on the quality of sleep they experience. Some recommendations which I gave was to enhance the robustness of future investigation. It is advisable to address existing data imbalance across various variables, ensuring a more representative sample. I also said, furthermore, evaluating the performance of diverse machine learning models and identifying opportunities for model enhancement, including feature enrichment and more advanced algorithms, could yield more accurate predictions and deeper insight into the complex interplay of factors influencing sleep quality. This refined approach has the potential to unlock valuable information for healthcare professionals and policymakers alike. So I also went ahead to end this by giving an executive summary. This executive summary covers from our data analysis and how we created our machine learning models. I stated the objective which we used in starting this project and the results which we discovered from each of these objectives. You can download this notebook and go through each of these results which I've talked about in our previous video, and I also talked about our model performances, and I said in predicting patient categorization into one of three groups, no disorder, insomnia and sleep apnea, linear SVC and logistic regression achieved the highest accuracy score, indicating their effectiveness in classification tasks. And I ended this by giving our key recommendations. So this project is very important. You can go through this at your leisure hour, because most of the times when we talk about machine learning models, our target variables which we are trying to predict are usually by labels like yes or no. Okay, so we hardly see projects that talks about multiple or more than 2 target variables. So with this, you can be able to tackle tasks or projects when our target variable has more than 2 labels that we are trying to predict. This brings me to the end of this video. Remember to subscribe to my YouTube channel if you found this video educative and useful. Also, share these videos to your friends, family and loved ones that you know are interested in machine learning and especially at-scale data analysis. This will be a very big benefit and help to them. Give this video a thumbs up and turn up your notification bell, and most importantly, drop your comments and question in the comment section below. I'll be going through them and try my best to answer each and every one of you. Bye for now. I'll see you in my next video.